Hi everyone. My name is Arvin. I am solution architect here in DSP Concepts.
And I'm Paul Beckmann. I'm the founder and CTO. And we're going to be showing you some new technology that we have in development at DSP Concepts. And what we're doing is we're making it easy to run ML models natively inside of AudioWeaver. Just a single slide to kind of kick off the discussion. On the left-hand side, we're showing what an ML model looks like. So it's essentially a connected graph of ML operators. So you might have convolutions, pooling, nonlinearities, and so forth. And on the right-hand side is an AudioWeaver signal flow. In this case, it's a directed graph of audio modules. And you can see that the underlying technology is exactly the same. It's a directed graph running in a real-time environment. So what we're doing is we're adding ML operators into AudioWeaver as modules. And that gives us a lot of flexibility to deploy. So we're going to do a demo for you, showing you an Alexa wake word. So here we're running on a RT685. So it's an embedded processor from NXP. And on the left-hand side, we have all the inputs coming. We pull off a microphone signal, we scale it, we high-pass filter it, downsample it, and then go into the subsystem, which does feature extraction. So you can see we're doing windows, FFTs, MELC spectrum, and so forth. So a bunch of features. And then we take the feature vector and we're sending it to the ML graph. And Arvin, how does this work? What does this module do?
So this ML graph, we basically parse the TF-Lite file in this case. We also support Onyx and PyTorch files. But in this example, we are parsing the Alexa TF-Lite file. And what it does is it will, behind the scene, fire up all the operator modules and connect it just the way it is supposed to be for TF-Lite inference. So when we say Alexa, and you can look at the sync window and be able to see the probability of your wake word.
So right here, we have a wake word model. It is trained to recognize Alexa. And so as I'm talking, there's no false triggers. Alec, Alexa, Alexa. And so now you can use this within a product that's doing a wake word, a smart speaker, AI assistant, and so forth. In AudioWeaver, you can also see the CPU load. So on the M33, this model is taking about 28%. And so you get all the advantages of AudioWeaver in a system like this. So we can easily take this model and move it over to the Hi-Fi 4. So let's go ahead and make a change here.
So we have a change thread module, and I can move the data from the M33 to Hi-Fi 4. And when I hit run, so now it is the feature extraction is still running on the M33, but the model inferencing code is running on the Hi-Fi 4.
Yeah. So it works just the same as before. Alexa, it'll identify and give you the probability of detection. You can also see the CPU load is lower. So this is the feature extraction, and the model takes about 3% on the Hi-Fi 4. So we've done a lot of work kind of optimizing this for different instruction sets. We're also planning on taking advantage of NPUs. And we can also do detailed profiling here inside of AudioWeaver. So it gives you a deeper look at not just the overall CPU load, but it'll profile the usage that each of the operators has inside of your model.
And one benefit of this is we can see potential model trainer be able to kind of tweak their model architecture to make their model more efficient for their hardware.
So inside the ML graph, you can see all the operators, and for each operator, you can see the CPU load and memory consumption. So this feature is still in development here at DSP Concepts, but love to hear from you if you're interested or have input on how we can make this better. Thank you.